Greetings, my name is Hardik Raj and today we will be discussing the problem Top Batsman. This is an easy level problem and the prerequisites are subset generation. This problem was asked in April Cook-Off of 2012. Let's look at the problem description. In the problem, we are given 11 batsmen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And we are given a value of k. Each batsman has some score associated with it. So A1, A2, A3, A4, A5, A6, A7, A8, A9, A10 and A11. And we want to select k batsmen from this whole selection such that the score of the k batsmen selected should be maximum. What I mean is, if we do 11 ck, this is the total selection, right? But out of these, we only want those selections in which the score is maximum. So let's look at the constraints. The number of test cases is less than or equal to 100 and the value of k is also less than or equal to 11. Right, and we know that the total number of subsets are 2 power 11, right? And then we need to iterate over these subsets. So 11 into 2 power 11. This will be the time complexity for a single test case, and for 100 test cases this would be something like this, and this will run in 1 second. So we won't be getting a time limit exceeded. Now let's look at the code. In the code, first I'm taking the number of test cases. Next, first input the score of each batsman, then input k, where k is number of batsmen to be selected. This map of int comment, it basically stores the score of a selection, and the number of ways in which that score can be formed. So for example, okay, right, let's say that a batsman has scored 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yes, 11, 9, 10, 11. Okay, and let's do this also as 10. Let's say this is 10 and this is also 10. Now what we want to do is, we will first check all the possible selections. That is, we can take either only one. It can be either this or this or this. Then we check for 2 selections. Then we check for 3 selections. Like this, we check all the possible selections, and in the selections in which the number of players are k, exactly equal to k, then we want only those selections, and in those selections we look for the score which is maximum. Then in this case it would have been 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say the value of k was 3. Then the selections could have been 7, 8, 9. Then the next selection could have been 7, 10, 11. Right. The next could have been 8, 9, 11. So yeah, and we want and in all of these selections the total score was 30. So we want the arrangements in which the score is maximum, and in this case it should be 30. So this is what we are doing. This is a pretty standard approach called submask enumeration. So now subset generation. So first the total number of subsets will be 2 power n or 2 power 11 in this case, because 11 is fixed. Then we check for the number of set bits. Bits indicates this is nothing but total number of players selected. So if the total number of players selected is exactly equal to k, only then we look at it, otherwise we continue. Now we check which of the players are selected in this configuration, and for those players we just increment the count, or sorry, we increment the scope, and at the end the number of ways it increases by 1. Now at the end this max score stores the maximum score possible, and ways stores the number of ways to attain max score. So number of ways to attain max score. Now we just iterate over a frequency array, a frequency map, and we just update the things necessary. That is, if the maximum score is less than the current score, increase the maximum score as the current score, and change the ways to x dot second. And at the end, just output ways. Let's try to submit this. Okay, as you can see, the solution was accepted. Now let's look at the space and time complexity. For the time complexity, this 2 power 11, this is nothing but 2 power 11 for generation of subsets, and in each of these subsets we need to iterate over the subset which is of length 11, right? So this is O of 11 into 2 power 11. This is per test case, and if we include the number of test cases, it would be 100 into 11 into 2 power 11. Okay, and as for the space complexity, this is almost constant space, because okay, sorry, for the space complexity, it is also O of 2 power 11, because there can be at most 2 power 11 distinct sums. So yeah, the time complexity is O of 11 into 2 power 11, and the space complexity is O of 2 power 11. I hope you understood the solution, and see you next time.